All right. So today we're going to look at the difference between improper fractions and mixed numbers and how to convert between the two. When it comes to these different forms to writing numbers, um, I tend to stick more to improper fractions because to me they make more sense. And mathematically speaking, um, it's easier to work with. However, many people in real world applications, especially when it comes to making measurements, they feel that using mixed numbers is a lot easier because you can see how many holes you have and then add on to the tail end just the smaller fraction that you need to. And I can completely see that, and I agree with that when it comes to looking at it in a real world sense. So both are useful because you need to understand how to utilize improper fractions and solve for them when calculating certain equations that you may need to. And then you would also need to be able to, in a real world application, in a real world sense, be able to use the mixed numbers. So if I want to know, hey, this recipe calls for 2 1/3 cup of something, oh, I can get 2 cups and then get a third of a cup. Instead of saying, okay, well, we'll see, that's going to be 7/3. I'll just take 7/3 cups. Ooh, you can do that. You can do 7 1/3 cups, can't you? Might take longer, but hey, you don't have to wash 2 cup holders now, do you? You probably don't care about that. All right. That's just an argument that I usually make with myself on which is easier. I don't have to wash 2 here, but I have to use that 7 times here. See, these are things that come up when it talks about using improper fractions versus mixed numbers. So for this class, you can use whichever you want unless it is specifically asked for you to use just one of them. So if a question says, hey, give your answer as an improper fraction, give your answer as a mixed number. If it just says evaluate or give your answer, that means you can do whatever you want as long as it's accurate. All right, now enough rambling about improper fractions versus mixed numbers. Let's get to the math. That's my favorite part. I'm sure it's yours too by now. If not, we'll get there. All right, improper fraction. So an improper fraction, I really don't even like that name because what they're saying is that, and I understand what they're saying. They're saying that if you had, for example, we'll use the one we had earlier, 7/3. That doesn't make any sense because you can't take one whole piece, break it into three, and say I got 7 pieces. You can't do that. That's improper. Yes, that is true. However, we understand what's really being asked here is what you're really being asked to do is to take 7 1/3 pieces. Quite simple. Well, how do we get to the 2 1/3 that we talked about earlier? That we said was the equivalent mixed fraction. And why is it called a mixed fraction? Because it's mixed between a whole number and fractional parts. So 2 is a whole number, 1/3 is a fraction. We write them both next to each other because there's an addition that's happening between these two. Yes, sometimes people say there's an imaginary plus sign there. I like to tell that to people, tell that to students. Why? Because it makes it easier to realize and so that you're not confused with multiplication like some people do when they see 2 1/3. Okay, again, I digress. Back to the 7/3 and the 2 1/3. Well, how do we make this look like this? Well, it's quite simple because if we said in the beginning, a fraction is nothing but a division problem. When you see this bar, that means you're dividing. 7/3 is really asking what's 7 divided by 3. Okay, we can do that, right? So how many times does 3 go into 7? Oh, it goes in twice. Well, cool. Well, what did you do next normally when you multiply it like this? And we saw whole number division before. If you're having trouble with that or you can't remember, go back and look at whole number division. Okay, so we'll multiply down. 2 times 3 will give us 6. We will subtract those numbers and we get 1. And we know 3 cannot go into 1, so we would say we have a remainder of 1, which makes perfect sense because we have 2 whole parts and we have 1 out of the 3 left over. That's how you write a mixed number from an improper fraction. Honestly, you could say that's how you always get a mixed number or a number from a fraction, any fraction. But anyway, okay, that's pretty simple. Well, how do I go the other way? Well, if we just look at what we did here and go backwards, then we will understand how we get back the other way. Well, the last thing that we did, well, what did we do first? We divided these two and got 2, and then our remainder was 1. It was how much was left over, right? Okay. So if we want to go the other way from mixed number to an improper fraction, all we need to do is multiply these two numbers, the whole number times how many fractional parts you should have. Well, that makes sense. That makes sense. See what I did there? That makes sense. Because 2 times 3 is 6. And if you take 6 third pieces, that would really be 2 wholes if you put it back together, right? Yeah. And we're just going to add on to that the remainder. And remember, this is all on the 3's. So 2 times 3, the whole number times the fraction, the fractional part, will give us 6 plus 1 more. So we end up with 7 thirds, which is exactly what we had over there, right? Okay. And so that's the difference between improper fractions and mixed numbers. How you can differentiate when to use them in a real world application. Improper fractions being more used and easier to work with when you're doing calculations. Mixed numbers easier to work with when you are actually measuring out things in a real world format. Both, as you can see, they can equate to each other. So sometimes people will do calculations into improper fractions and then convert that to a mixed number so they can tell someone, hey, go get 2 1/3 cups of flour so we can bake these cookies. So it's up to you, honestly, and really. But the most important thing that I want you to leave here with is knowing that they're the same thing. It doesn't matter how you represent the number. It just matters to the person that's receiving it. So if your boss says, and in this case situation, I would be like your boss if you think of this is a business case, and I say, give your answer as an improper fraction. You can do all your calculations in mixed numbers. You can do all your calculations as whatever you want. But in the end, when you turn that paper into me, it says an improper fraction. If I say, give your answer as a mixed number, you can do all your calculations in any form you want. They can be in improper fractions all day long. But when you give your answer, you give it as a mixed number. And if they say, I don't care, give me the answer, then guess what? You can put whatever you want. And they probably realize that they're able to understand what it is that you are giving them. And they expect others to do so as well. So if you're one of those people that's always like these mixed numbers as opposed to improper fractions, when you get out into the world, if someone gives you an improper fraction, it's important for you to understand that that's the same as this mixed number. And if you are one of those that I hate writing mixed numbers, like me, too bad. Even for myself, too bad. This is used a lot, as I said earlier, with measurements. So if you don't understand this, then you would have an issue when trying to measure things out or to build something or to create something based off of a recipe or an exact list given to you. So have fun. I'll see you soon.